it's like light over here, but it makes it dark over here.
Come on, we need a lighting assistant to work better than that.
Let us know when.
Is that better?
You know what it is?
Oh yeah, it's like, see how it's like dark over here?
I'm trying to get as close as we can to Brian. It's so small.
No, well, you have to just deal with it, I guess.
Okay, we'll deal with it.
Okay.
All right, here we go.
Close enough. So here's the deal. On the brain, first of all, when you look at it together, you have your two hemispheres. So if you're looking at the brain like this, remember that the brain stem is going to be posterior, the other side's going to be anterior, making this the right, this the left.
Okay.
Okay? We also need to look at the lobes of the brain. We have the frontal lobe, this is going to be on the front here, frontal lobe. The parietal lobe is going to be more on top there. The temporal lobe is going to be on the side of the brain, like that. Now here's where people get confused. The occipital lobe is not here. It is the back of the cerebrum. So back there, that is the occipital lobe. Okay? This guy is then the cerebellum. Okay? And then of course we have the brainstem down here. If we flip it over, let's see if I can kind of make this look half decent here. Okay, we're looking at the optic. We have three things in this area: optic nerve, optic chiasm, optic tract. The optic nerve runs from the eyeball, which would be out here, back towards the centerpiece. So this and this would be your optic nerve. Where the two X's, piece of the X meet right in the center, right there, that would be the optic chiasm. And then from the chiasm posterior, which we know is where the brainstem is, so this is going to be posterior, from here to here. So that is going to be the optic tract. Good there? Back on this side, we also have to think about the gyrus versus the sulcus. All of the raised areas, so that is a good example. That would be a gyrus. All of the lowered areas or the valleys in between, that right there would be a sulcus. Okay? If we open it up and look at the inside here. Okay, on the inside, this white piece that goes from here all the way across to here, and if I were to pin it singularly, it'd be probably something about like that. Okay? Notice the connection between right and left side. It's going to be white matter, so it's one of our tracts we talked about. This is the corpus callosum. Okay? The corpus callosum is one of our commissural tracts. So it's the corpus callosum. Immediately inferior to that is this big hollow space, and that's our lateral ventricle. Remember, ventricles are just hollow spaces. So on the test, make sure that the question asks you to identify the space or the hollow area, the cavity, something along those lines. Just below that, the next space that we have is right here. Okay, that is the third ventricle. Now in the same area as the lateral ventricle is the septum pellucidum. That is a membrane that would connect this to this. Now on this side it's not there because you can see right inside that hole. But if we look at the other side, the same area, you see how there's a membrane connecting these two things here and you can't see inside the hole. That membrane right there is the septum pellucidum. So again on the test, I'll have to pin in the exact same location as I did the other side, only I'll ask you something like, ID this membrane, ID this structure, ID this, I don't know, wall, tissue, something along those lines. When I ask for a tangible object, not a space or a cavity, then I'm asking for the septum. If I ask you for the cavity, like over here, what's the hollow area, the cavity, the space? That's the lateral ventricle then. We then have brainstem. The whole thing is the cerebellum, and then the white part in the cerebellum looks like a tree. Right there is the arbor vitae. And I believe that's everything, isn't it?
Really?